All right, so here we have 3, 2, adding and subtracting and multiplying polynomials. And the I can statement is add, subtract, and multiply polynomials. It's not a hard section. Of all the sections in Unit 3, this is probably the easiest, but, will everybody be able to do it? I don't know. So our first example is simply adding and subtracting like terms, and that's all this is. Now, in standard form, the highest exponent comes first. That's just the way it is. Now, they happen to be color-coded here, but you guys have black and white copies, but all we have to do is combine our like terms. This is 6x cubed. See the plus symbol? It's not FOIL. Plus 2x cubed is 8x cubed. We have a negative 8x squared and a positive x squared. You put them together, that's negative 7x squared. We have a 4x over here, and then we have a 3 over here. It's not you shouldn't have a problem with that. So we're not going to spend more time on it. Kids are going to have an issue with subtraction. That's a given. The main thing that kids don't do is kids don't distribute the negative sign. It doesn't matter how many times Milbrath tells you that. You just won't do it. I don't know why you won't, but it's the big mistake. We're just going to distribute that negative sign. Minus 2x squared y squared. Minus 3xy squared. And then plus 2x squared. Now, we're going to focus on these funny things first. Those are like terms. Probably shouldn't use purple on purple there. Could have swore I just changed it. There we go. Those are like terms. I notice they both have an x squared, y squared, and all I'm going to do is focus on the number. 3 minus 2 is an understood 1, so there's an x squared, y squared. Now, the next funny looking things are that guy and that guy. Notice they both have an xy squared, and they are like. And 2 minus 3 is negative 1. Remember, in math, ones are understood. I say that a lot, but y'all still don't seem to get it. The next highest power is going to be that guy, and he's the only one that exists. And then finally, we have the plus 6x. And that's how that thing would look in standard form. Of course, you have a used structure here. In order for terms to be like terms, the variables and their corresponding exponents must be identical. All right, so we're going to do this one of two ways. The classic way would be the distributive property, which I have no issues with. The only problem with the distributive property is things tend to be out of order. 2m times 3m squared is 6m cubed. 2m times negative 4m is minus 8m squared. 2m times 2 is plus 4m. Then we're going to distribute that 5. 5 times 3m squared is 15m squared. This is the reason why the distributive property gives kids some issues. 5 times a negative 4m is minus 20m, and 5 times 2 is plus 10. Now, grouping like terms, for some kids, this is a challenge right here. Like, this is a legit foreign language. I don't understand the issue. I just know that it is an issue, so that's gone. Next up is these two. 15 minus 8 is going to be plus 7. Gone, gone. 4 plus a negative 20 is minus 16m. And then finally, we have the plus 10. I legit think for the vast majority of kids that are not, a STEM-bound major or whatever, I really think that the box method makes more sense. I don't know why I wrote bomb, probably because it's 6:06 in the morning. So all you guys know, the box method has just been a product of two binomials. But here, the box has to be a little different. One side is going to be the 2m plus 5, and the other side is going to be these three pieces. And hopefully you can understand why I drew the box this way. Because I had to, right? That's why. All right, so m times 3m is going to be a 6m cubed. 2m times negative 4m is negative 8m. 2m times 2 is 4m. 5 times 3m squared is 15m squared. 5 times negative 4 is minus 20m. And 5 times 2 is 10. And the nice thing about the box method is group terms tend to be somewhat organized. And you can see that happened here. It did. The m cubes, of course, by themselves. The next variable would be your m squareds. Notice it's all there just by itself. And here we have the m's. There are negative 28 of, I made a mistake somewhere. And I made it here, didn't I? Oh, look at there. I'm glad I checked myself. 2m times 4m was 8m squared. Oh no, the mistake's right here. That's a square. Ah, bummer. Go back and fix that. That's a square. 15 minus 8 is positive 7. Oopsie poopsie. All right. This diagonal right here has got my m's. That's what I should have been looking for, is the diagonal. Negative 20 and 4 makes 16, so minus 16m. And then finally the 10. Boy, I kind of borked that, but I promise you that the box method is actually faster. It really is. Past double distributive property, I think the box method wins every time, time constraints. So here we got this one. Now, how do you do this? Well, first off, you're going to pick two binomials and either FOIL or box. So pick any two binomials and either FOIL it, we call that the double distributive property, or box method, whichever. And then you just repeat the process. So I'm going to pick on these two. I'm just going to go ahead and do the box method. Mn times mn would be m squared n squared. Mn times 1 is mn. Mn times negative 2 is minus 2mn. And negative 2 times 1 is minus 2. And you can clearly see that this becomes m squared n squared minus an mn minus a 2. Now, there's still this guy. Now, a lot of kids will stop here and be like, oh, that's an answer choice. I'll pick that. Or they just stop. There was more to do, right? Looks to me like there was. Doesn't really matter which one you put where. I'm going to put this along the side here. Mn squared minus mn minus 2, and then mn plus 4. Ooh, that's a bad looking m. No, what have I done? Ah, cool. It's close. All right, now m times m is m squared. N times n squared times n is n cubed. 4 times anything, just the 4 anything. Negative mn times mn is a negative m squared n squared. And minus 4mn. Negative 2 times mn minus 2mn. And negative 2 times positive 4 is minus 8. All right, so let's scan this thing here. I see an m squared n cubed. That's my first term. M squared n cubed. These guys aren't alike. They're close, but they're not quite. Minus m squared n squared plus 4mn squared. These guys are alike. Minus 6mn. And then finally minus 8. So yeah, it's going to take you a minute. Big whoop. What else you got to do with your time? All right, so here we have a try it. I'm only going to do example B. And you know what? Let's do this the classic way, which is to double distribute. M times m squared is m cubed. Get this out of the way. And then you have n times n squared minus mn. All right. That was first and outside. 1 times m squared n is plus m squared n. And then 1 times negative 1 is minus 1. So I have done all that work right there. Nothing in here is alike. I'm going to have to turn around and multiply that by mn squared plus 2. Again, you pick whichever thing you want to do. If you like foiling, double distributive property and such, you just go with that. No big deal. All right, we have m cubed n squared times mn, which is m to the fourth. And then we have n squared times n squared, n to the fourth. Then we have m cubed n squared times 2, so plus 2m cubed n squared. Moving on with our lives, we have a negative mn times an mn squared. That's going to be negative m squared n cubed. Negative mn times 2 minus 2mn. And again, moving on with our lives here. M squared times mn would be m cubed n cubed. M squared n times 2 would be plus 2m squared n. And finally, we have the negative 1 times everything. So minus mn squared, and then minus 2. Of course, now we have to go through this process of like terms and exponents and stuff, which isn't a big deal. This guy is going to win the war here. M to the fourth, n to the fourth is the big dog. Let's see here. M cubed n squared. Is it supposed to be in? I don't see another one of him. I see some things that are close. But this is the next one. We have this plus m cubed n cubed. Get rid of that so I ain't got to look at it. Then I see an m cubed n squared plus 2m cubed n squared minus this one, which is m squared n cubed. None of these things are alike, are they? Plus 2m squared n minus mn squared minus 2mn minus 2. What an ugly looking polynomial. Yeah. All right, last one. The length of a rectangular speaker is 21 minus its width, and its height is 4 more than its width. Write an expression of the volume of a rectangular prism in terms of its width. So you are expected to know that the volume of a box, a rectangular prism, is length times width times height. Now, if you don't know that, I don't know. I just don't understand you. It's length, width, height. So we're going to call the width x. Well, actually, we're going to write it as terms of w. So let's do this properly. The volume as a function of w is its length, which is 21 minus the width, times its height, which is 4 more, times its width w, times its height, which is the width times 4. Now, if we clean this up, this is how it would look. It would look like w times 4w times 21 minus w. Now, on the EOC, what they like to do is they like to do a little bit of just a near math here and say like this is 4w squared times 21 minus w. And that really throws kids off. Like when they don't finish it, they just do a little bit of it. All right, look at the graph of the function and determine a reasonable domain. So obviously you're going to have to go to y equals here, right? I'm going to type in this one here. Now, instead of a w, we shall use the x key. So I've got x on y, I'm in y2. I don't need to be in y2. We've got an x times a 4x, and then times a 21 minus an x. Now, we're going to do a Zoom 6, but it's going to be completely useless to you. I do want to talk about this thing. If you did w times w and the negative, you'd have negative 4w cubed. From end behavior, I expect this thing to start high and end low. That's what I expect to happen, okay? And you're gonna have to play with the window quite a bit to see this graph. Like that's all you see is you see it come in from up high and then shoot up. And the box is quite large. And I only know this from doing this example earlier. Play along, but I'm gonna set the Y max to be about 7,000. And I'm gonna look out about 40 units on the x-axis, which is probably too much. Let's look out 30 units on the x-axis. So x max is 30, y max is 7,000. Hit the graph key so you can actually see the picture. And again, the only reason I know that is because I played with this problem earlier trying to speed the video up. And there we go. This is what I expected to happen. It started up high and it ended low. Now, a reasonable domain, this stuff over here doesn't make sense because this is where the width is negative, okay? Looks like that's it. Now, let me play with the window some more here. Let's set a y min of like negative 1,000 so you can see this. Why are certain things not worried about? Remember, this is volume. The graph represents volume. Down here, what would the volume be? Would it be positive or negative? It's below the x-axis. If you're thinking negative, winner, winner, chicken dinner, thank you for paying attention and paying attention, all right? So the only thing that makes sense on this graph is this stuff right here. Now, this should be 21 on the money. It should be, because 21 minus 21 is a 0 of the function. You see what I did there? Maybe did, maybe didn't. Let's hit second, trace, go to 0. And we're going to take our cursor and we're going to get it left of that 0. We're going to press enter. We're going to get it to the right of that cursor, press enter. Then we're going to enter one more time for guess. And by God, it was 21. This one is quite obviously 0. So the domain is any number stuck between 0 and 21. Boy, I am struggling this morning. All values of the width such that the width is stuck between 0 and 21. Or you could just say 0, 21 if you like set builder, or sorry, if you like interval notation. What value of W maximizes the volume? I need a wakey, don't I? That's going to happen right here. Right there. So we're going to go through the process here at second, trace 4 for maximum. It works by knowing the difference between left and right. Some kids do, some kids don't. We get left of the maximum when we press enter. Then we get right of the supposed maximum, we press enter. We press enter a third time for guess. And there's your maximum. Your maximum happens when W is 14. And then you can have the max volume too. It's also 5,000 something. 5,488 cubic units. And that's it. Hope you enjoyed.